Good morning or afternoon to everyone. My name is Akmal Farhan bin Mahizul. Today I will present my quality, which is my case study title, Reducing Door Assembly Defect Using PGSCAN Quality Tools at PEBS GV Vehicle Assembly Melaka. The focus of the study is to reduce quality defects in the vehicle door assembly process. For the introduction, in the automotive industry, quality is very important because customers expect vehicle to be safe, functional, and visually perfect. One important process is vehicle door assembly. If the door is not installed properly, it can cause problems such as door misalignment, water leakage, white noise, and improper locking. The study focuses on identifying the main defects and improving the assembly process using quality measurement tools. For the table of content, these are the topics that I cover in this presentation, which is problem statement, data collection, Pareto analysis, root cause analysis, proposed solution, validation and result, control chart, and compression and recommendation. We'll go next to the problem statement. For the problem statement, several defects were found during the door assembly process. The two main defects that I have occurred is the one is the improper sealant application, which is the waterproof seal is being applied incorrectly. So the second one is the electrical connector, which is side mirror cable connector are not fully clipped. If these problems are not solved, the company may face higher production costs, material waste, safety risks, and lower production efficiency. For example, repairing defects at the final stage require more time and manpower. For the slide 5, we have the data collection, which is the consequence of inaction. The data was collected from the Hub-6 door trim line throughout last year 2025. The check sheet was used to record a date, defect type, defect position, countermeasure, and taken. For the some example include side mirror cable full clip, which is more concerning, and maybe some happen from the wrong installation of the handle, and maybe some can door unable to lock. For the cost and waste, identifying the defect at the final stage is to inspect offline the work and the waste. For the safety risks, the faulty mirror correction cause visibility issues such as poor seal leads to water ingress in electronic. For the efficiency loss, production flow is interrupted, lowering the total unit produced per shift. For the data collection check sheet, this is compression monitoring that I said earlier, that across the harvest is you see the first one is the side mirror cable, and the last one is the front left handle door is unable to lock. That the countermeasure is the company used some Pokayok implementation to ensure that the problem will be repaired accordingly to the date after the defect been detected. For the Pareto analysis, uh, the Pareto analysis was carried out using the collected defect data. The results show the vehicle door misalignment was contribute 48%, and the frequency is count by 72, and for the improper waterproof seal contribute 32%. Together, these two defects contributed 80% of the total defect. These follow the 80 per 20 principle, where a few major causes create most of the problem. Therefore, the company should focus on this critical defect first. For the root cause analysis, root cause analysis was conducted using the 5M approach and the 5 Whys technique. The several causes were identified, which is for the main and method, the fatigue due to hypertension, targets, and maybe some of lack of proper inspection checkpoint after some operator install the door parts. For the machine and measurement, maybe some worn out tools that have been lack of predicate to the regular calibration. For the material and environment, maybe some poor quality leadership due to the dust in work space, which is maybe effect to the seal quality and some of the poor quality real estate material. The analysis concluded that operator workload and weak SOP implementation were major contributor to the defects. For the solution, that maybe I have been idea is for this. Solution 1 is maybe we can use Pokayok in standard work cleaning, which is include mechanical element jigs or standardize more on SOP training or better operating guidance before work. And for the solution 2, maybe we can using automated vision inspection system and schedule tool calibration group, which is to carry out regular calibration and maintenance checks for tool and alignment sensor to ensure the tool equipment work accurately and reduce production error. For the validation, after implementing the solution, new data was collected over 30 days. The results show major improvement, which is for the door misalignment reduced from 72 to 10 cases, and improper sealant defect reduced from 48 to 8 cases. For the total defect is around 85% improvement. This proves that the corrective action were effective. For the control chart, the control chart was used to monitor the defect rate after implementation. The chart shows that the process become more stable and consistent over the time. This means the improvement successfully help maintain quality performance. For the conclusion, overall, this case study successfully applied the PCS cycle and quality tools to reduce defect in the automotive door assembly process. The main defect identified were vehicle damage element, improper waterproof seal application. Several recommendations are suggested, which is maybe continue operator training. The second one is maintaining standardized SOP. The third one is improve ergonomic and manpower planning. The last one may be perform a regular tool maintenance and calibration. This action may be for us as a student can help GV Melaka maintain better product quality and reduce future defects. That's all from me. Thank you.